Alright, asymptotes and limits at 0 and infinity. This is one of the hardest sections of the year for a lot of people. I say in the intro, the section is difficult and requires analysis of the function to figure out more challenging limits. I made this section because I think that being able to analytically go through a limit is a very important skill. It's important to know whether or not something converges or not by understanding how functions look, and that's kind of what's tested in this section. I give more practice problems here at 17 Calculus, so if you want to see more beyond what I'm going to do just now, you can go check there. And now, let's just jump straight into this problem here. And this is because I copy-pasted this bad. Alright. Oh geez, look at this thing. So, first things first, we have a limit as we're approaching 0. We should just see if we can plug in 0 and see what happens. Alright, first thing, 0, 0. If we plug in x as 0, we're just going to get zeros everywhere there's an x. So that means all of these terms go away. And all we're left with is square root of x minus 7 over negative square root of 4x minus 1. But the x's are zeros, so I should have just plugged in zeros for those. So we just get 0 minus 7 and 0 minus 1. Now both of these are exceedingly problematic. When you're doing these problems, it's really important that you remember all the different ways we can break math. It's dividing by 0 is bad. A negative in a square root. This is negatives in square roots. We have a 0 minus 7 in a square root. From either side, as we go towards 0, like coming from x is 1, it's still going to be negative inside. Coming from negative 1, it's still going to be 0 or negative inside. So this is exceedingly problematic. This is never going to work. This function doesn't exist until at 7. So that's why the answer is undefined. This is bad. There's nothing here. Now let's change this problem a little bit and look at it, say if this was a case where these things weren't messing us up here. So let's look at perhaps just this. So all I did was pull off the square root terms that messed us up in that problem. If we were trying to evaluate this guy as x approaches 0, when you're plugging in really small numbers and then you square or cube them, you need to remember that those terms are going to get small way faster than just the normal x terms. So the smaller the power is, the bigger it is as you're approaching 0. Which means we can just ignore all these and look at these two terms. And we have negative 9x on the top and 11x on the bottom. Since those x's will be the same because we're plugging in the same value for both of them, this thing is just going to approach negative 9/11ths. Oh, geez, what happened there? So that's why this section's tricky, that you need to be able to evaluate the problem and go, oh, geez, this is going to ruin this problem, or okay, what do I do if nothing ruins the problem? What if this is actually a problem that works? And so that's how you go about doing it. Alright, guy on the right side is significantly simpler. It looks simpler. Let's think about what sine of x looks like. Sine of x looks like this. I mean, that's a crappy drawing, but it goes on forever. Does it ever converge? No, it keeps doing its thing. All these trig functions just kind of keep doing their thing. So as you go out to infinity, like we could skip. How do you do the skip drawing? You go like this, and then this is up at like a million. It's still doing its thing. It's still just going up and down like a sine function does. So this never converges. It's always going to be between negative 1 and 1. It's always going to bounce between them. So this one's also undefined. Now something that happened last year is anytime people saw trig functions in a limit at infinity or 0 problem, they went, oh, that's going to mess everything up. That's undefined. That doesn't work. So let's look at an example where that wouldn't work. So let's look at an example down here where we're like, okay, this is our bottom. And our top is just going to be 5 plus x squared. And we're just going to do the limit as x approaches infinity. So say I gave you this problem. This would just be 5 at infinity. This would be going to a big number. So this is like super big. This is just 10. So basically these don't matter at all at infinity because this is already super big. However, it is important that we keep track of the 10 here on the bottom because we need the bottom not to be 0, and we need to know whether this oscillates between negative and positive because that would really mess with the total value of this function. But sign just goes between negative 1 and 1, which means this bottom's always between 9 and 11. Which means it's always going to be positive because anything squared is positive and we're always dividing by a positive number. And this is getting super big. And these are not. These are just staying between 9 and 11. So this thing is actually going to infinity, and so we'd say that the limit approaches infinity. So it really depends on what's going on in the problem. And you can like ignore things when you're considering certain things. Like up here we ignored all of this stuff because we said, okay, these could be problematic. And we said, oh, negatives and square roots, that's no good. Negatives and natural logs, that'd be no good. But in these cases where we were able to actually analyze, we had to be a little more creative and go, okay, how does this affect the function when I plug in a really big number? That's what makes this section hard. I hope this video helped you understand how to go about solving these, and I hope what we do in class also helped. Later.